Good morning, Rainier Christian School teachers. Go Mustangs. Hey, one of the things I'm really thrilled about this year is the shift in our mathematics program for K-6 students. As you know, there are really two separate pieces to this math adoption. One of them is the program, the Envision mathematics program, and our Friday focus on non-routine and novel problems. In fact, I've been sharing with prospective families that the Friday focus will be on such problems and have given them an example of a non-routine problem that their students might actually see in the upper elementary grades. I'll share that problem a little bit later. However, I believe that anecdote was very influential and persuasive for one of the prospective families that toured recently. As you know, or may not know, our Title II funds from the neighboring districts pay for our professional development. And this year, unfortunately, I encountered the most severe and stiffest headwinds trying to get those dollars directed to our students. The delay in duking it out with Kent School District resulted in not being able to provide the planned training from Sabas on time. I did prevail. We had to go to OSPI and really hash this out, but I knew my interpretation of Title II, was correct. excuse me. And that those resources are going to be available in some subsequent professional development days. So the workaround today is we will spend some time in Java-like teams looking at the Savas materials, but I want to begin with what my expectations are around Friday's non-routine and novel problems. And there'll be some resources that you'll view shortly that will look at that. And it's broken down into really three separate pieces. The first of all is reusing Poya's problem-solving approach. George Poya was a brilliant Hungarian mathematician he's a Stanford professor. And his model, he was an archetype for problem solving in mathematics. We'll take a look at that a little bit later today. So that's the first part, is understanding what his process or his approach was for solving math problems. The second part of this is becoming familiar with a set of problem solving strategies. And in elementary school, there's 8 to 10 or so problem solving strategies that students learn over the course of time. And this will be part of the initial part of these Friday focus sessions in mathematics. Students understanding what Poya's process was, his 4-step problem-solving approach, and then learning about individual strategies for attacking and solving problems. Here's the thing. I don't want elementary students who leave Rainier Christian schools thinking mathematics is only about solving worksheets or problems on a page or from a book. Because math is more about a way of viewing the world and attacking problems with particular insight and high-level thinking strategies. I want students to be well-versed in that. No one has ever gotten through the entire curriculum in my understanding, and if you're trying to do that, we need to get through the entire book or whatever. Please don't entertain that thought. That's not the important part for me. I want students to be able to walk away with tools in mathematical tools to help them solve these non-routine and novel problems. So when we look at Poya's problem-solving approach, those 4 steps, some problem-solving strategies, different techniques and ways to get at problems, and then the last piece is the actual problem sets. And that's where there will be some work that needs to be done. We did our session on ChatGPT, and if you type in, I need non-routine or novel problems for 2nd grade students, it'll spit something out, and you can say, try it again. It'll give you a different problem. So we'll be able to share the load. My vision for this was that our Java-like teams, one teacher could find a non-routine or novel problem for 1 week, and the teacher at the other campus could find the novel or non-routine for the following week, and we can share those problems back and forth. So here's the famous locker problem. You may have heard it before. It goes like this. At a particular middle school, there are exactly 100 lockers lining a hallway. And at the end of the school year, the custodian gives the students some instructions. And the first student shows up in the hallway and he opens every locker, 1 through 100. Right after that, the second student comes in and closes every second locker, 2, 4, 6, and so on. The third student, however, comes in and changes every third locker. If that locker was closed, she opens it. If the locker was open, she closes it. And that pattern continues, fourth student, fifth student, and so on, until all 100 students go through the hallway. So I hope you've understood the problem, Polya's first step. So the question at the end of this scenario, or this non-routine or novel problem, is this: how many lockers are closed after all 100 students go through the hallway? That's a great example of a non-routine or novel problem because the answer is not immediately evident, nor is the strategy in which one would need to pursue in order to solve it. So I don't know if you'll have time today to work on that, but that's what I like to see happen on Fridays. After the students get through their understanding of the problem-solving approach, Polya's four-step method, once they have access to a set of tools or strategies to solve problems, we would then begin to introduce these novel and non-routine problems. Anyway, God bless you. Thank you again. I'm really excited for this year. I look forward to seeing kids engage this way on Fridays and also with some real robust materials for mathematics. God bless you, and I'll talk to you soon.